with that, we're actually going to get started and talk about Tinkercad. It's a pretty fun and it's easy to use. It's really good for prototyping. The nice thing is you can build whatever you want. It's free, and if you're just practicing circuits, you won't have to blow anything up. It'll just give you a warning sign, and it's a really good tool. The thing you want to remember, whether it's a competition or entrepreneurship or really whatever you're doing, you always want to do the $5 experiments before the 50 and the 50 before the 500. So using tools like Tinkercad, even if you know how to prototype, will really help you with your just your design build test process. And it has built-in Arduino programming, so it's like a one-stop shop. It's perfect. I'm going to ask that all of you go to tinkercad.com/circuits, and we're going to set up accounts for everybody right now. It's really, really simple to sign up with. You should be able to, go in, say, create new accounts, and this is what it'll look like. It'll ask you how you want to sign in. I just clicked with email, and you'll, thank you, Tara, for putting it into the chat. You'll be able to, you'll see these different options. You can sign in however you want. Generally recommend that you use the email that you used to sign up for this workshop. And then after that, you will be able to see your Tinkercad. I'm going to pause for a minute or two and see if everybody is able to get into Tinkercad. If not, happy to help you troubleshoot now. Have Tinkercad set up. We're going to go through the example project that we have planned for today. I'm going to show you what it is, and then I'm going to walk you through the code part of it, and then we're actually going to go through and build it together so that we can see how Tinkercad works and then how the coding part works as well. So this is what we're going to do. We're going to make a really simple temperature-based cooling system. How this works is this is your temperature sensor. You can set a number of different thresholds. And I've said, hey, my baseline temperature is 0. If it goes 10 degrees above, turn 1 LED on. If it's between 10 and 20 degrees, turn 2 LEDs on. And if it's more than 30 or so, turn all 3 LEDs on. And after 2 LEDs are turned on, this fan also turns on. It's just a DC motor, but it's pretty representative of a fan. That's how you would sort of start building the physical circuit. Some of the things you're going to need are a breadboard, one of your temperature sensors, 3 LEDs, whatever color you choose. This is wrong. You need 3 220 ohm resistors. That's a typo on my end. And you're going to need the wires and, of course, a DC motor. So some new concepts we're going to talk about are things like constants, variables that don't change. So you can say, you can declare a variable as a constant and it's going equals to 10 and it's not going to change. For example, if you set baseline temperature as a constant that's equal to 0, it's not going to change. It's not, it's going to be 0 for the entirety of its code. The next is a float. It's a type of number that has a decimal. The next concept is serial.begin. And basically, this prints information into your serial port. And a serial port is basically a window that the Arduino has once you start running your code, where you'll be able to see the outputs of your code, or if you have any print statements. And what 9600 is it's the baud rate. That just means it's sending 9600 bits per second to the serial port. And then we're going to talk about for loops, and then if and else if, right? If you just have 2 conditions, you can do if and else. If you have 3 conditions like we're saying if it's less than 10, more than 10 and 20, and then 20 and 30, and then 30 or plus, right? We're going to use things like if and else if. And then we're going to do analog read. Much like analog read, there's a digital read. The difference is you're telling your Arduino to read either from an analog pin or a digital pin. So your temperature is an input, right? you're connecting it and it's reading from the ambient temperature, it's reading from your environment and telling your Arduino what that input is. It's again going to be in terms of a signal, an arbitrary signal that we're then going to convert into a voltage. And then we want to print it. So we're going to use the function serial print. Maybe we want to print it on a new line to keep things nice and tidy. So we're going to use serial.println to print on the next line. So here's just a quick intro to what the code's going to look like. So you'll see that we're declaring some of our variables, right? We're setting a constant integer, sensor pin is equal to A0. This is where we're going to connect our temperature sensor to, and then a constant float. Baseline temperature is equal to 20. So this is 20.0. It's going to stay at 20.0. I set it to 0. You can set it to whatever you want it to. Maybe your fish tank needs a minimum temperature of 60 degrees Fahrenheit, right? You could then convert this into Fahrenheit and then put it at 60. Remember that the operating temperature unit is Celsius. So if you want to convert to Fahrenheit, there's going to be an extra line of code. The next thing is we have our void setup, right? We're telling our serial monitor to, start tuning in. Hey, I'm going to be sending you information at 9,600 bits per second. Start looking for it. And then we're saying, we're basically declaring inputs or outputs for all pin numbers 2 to 5. This is just an kind of a fancy and kind of an unnecessary way of writing it. It simplifies code. It makes a lot of sense if you've got 10 or 20 things that you're trying to set as output, but it's probably a handy tool for you to have. So for what this is saying is for pin numbers 2 until pin number 5, pin number plus means from 2 to 5, keep going to the next one. Plus means +1. So basically it's pin number 2, then it goes to 3, then it goes to 4, and then it stops because it can't go to 5. We've said until it's less than 5. So then it stops. So the for loop is running, and now we're giving it functionality by saying pin mode, right? That's pin mode is telling what the pin will be set as. So here we can call it output. If we said input, it would be an input. We're going to say for pin number. So all these 2 to 5 that we've defined, they're all going to be outputs. And then we're going to say digital write. So all of your LEDs, digital will be or anything connected to any of the digital pins that you've connected, they're going to be set as low, which means the default state, your LEDs will be off. And then the next thing we're going to do is analog read, right? We want to tell your code to read from the analog pin for your temperature sensor. And so we're going to say, well, the sensor value that I'm getting from my sensor pin, remember we defined sensor pin here as A0. This is basically the pin that your temperature sensor is connected to. Anything that's coming from that, I'm going to define it into a new variable that is going to be stored as an integer. We don't want floats. We just want integers, right? 29, 30, 31. And that's going to be saved as sensor val. And then
Achala, there's a hand raised.
Oh, yes. Sorry, I'm not able to see that. Definitely. What is your question?
Okay. I wanted to ask what the default reading from the temperature sensor was. I missed that. Was that Fahrenheit or Celsius?
The default reading is in Celsius.
It's in Celsius.
So the TMP sensor, yeah, the TMP36 sensor is for centigrade, so Celsius.
Okay.
Yeah.
And then for this void setup, can I just, I mean, I know that this probably works, but can I also just say pin number, comma 2, 3, and 4 instead of doing this?
Absolutely. You can totally do that. This is just a snippet of code that I wanted to introduce because you guys are likely going to create more complicated circuits. And this might just be a faster way of declaring inputs and outputs.
Okay.
But yes, you can just go pin number equals 2 output. You can just write this, right? Get rid of the for loop, write pin mode 2 output, pin mode 3 output, so on and so forth.
Okay, thank you.
Yeah, no, happy to answer questions. Again, I don't necessarily see the hands raised or anything, so if you have questions, feel free to unmute yourself and ask. Okay, so the next thing, this is where things get a little complicated, right? We want to convert our readings from analog to digital, and the Arduino sort of does that built in. Actually, just give me a moment. Okay, so the analog does that built in. It has an ADC called basically an analog to digital converter. Actually, that is what it is. And it's a 10-bit ADC. And so what that means is it can store 2 to the power of 10 pieces of information. And that's where we get that 1024 value from. 2 to the power of 10 is 1024. So what we're saying is we want that raw voltage value, right? So that we can then convert it into a temperature value. If we know the correlation between temperature and voltage, we can come up with a relationship to figure out how many degrees Celsius it is. Remember, the sensor, while its default mode is Celsius, it's still going to be outputting just arbitrary sensor values. We can print sensor value and see what they look like. But to get that raw voltage, we divide that value coming in by the total possible number of storage units within the 10-bit ADC converter. And then we multiply that by our 5-volt input, right? We've got, so this is unitless, and then to get a voltage value, we multiply it by our input voltage of 5 volts, and we get the voltage value. That's how we go about this. If it's a little arbitrary, this is just generally how to go about it. Just think about it as your sensor value divided by the number of storage points, right? 2 to the 10, and multiply that by your input voltage. And then we want to print that voltage so we're able to see what that looks like. And we'll use that with serial.print. And then anything you put in quotes will just show up as is. It's basically a string. And then if you put print.voltage after this, you'll be able to print the actual voltage value that's being stored as a float.
Can I ask a quick question? Why the main line right under void loop, why do you have that set as int rather than just the sensor val equals?
So I want to store my sensor values as an integer. You could store it as a float if you wanted, but you have to store it as some sort of data type, right?
Okay.
You have to tell the Arduino to store it as some sort of numerical value. You have to declare some sort of data type to your variable.
Okay, and that's because you're doing that as analog read?
Even if you're doing it for digital, you have to either declare it as an int, float, a string. There's a number of different types that you can declare the variable as. You have to tell your computer how you want to store it. And that's all you're doing. I'm telling my computer I want to store it as an integer instead of as a number that has decimals.
Okay, thank you.
Yeah, and I could go back and change it as float or even string and have it save as just a string of numbers. But for this purpose, because I want to do mathematical operations and I want to keep the number simple and tidy, I'm going to save it as an integer. And so we're going to be able to print all of these values. But the next thing we want to do is then convert that voltage that we've just taken and turn it into a temperature value, right? So the relationship between temperature and voltage is given by this equation, and you're like, well, how does that happen? And we'll talk about how that happens in just a second. But the concept that I want to introduce on this slide is the print.ln function. right? So in a single line, right, serial.print just keeps printing. It's not going to create a new line. Everything is going to be on the same line so far. And know that the void loop runs continuously. So let me actually go back here and clarify. Where did we go? Okay, I guess I'll just say it here, right? Your void setup runs once when you execute the code. It just tells you where to find things, but then your void loop keeps running endlessly until you stop the code or disassemble or turn off your circuit. So that's how that works. So your code is going to be running continuously, which means you're printing all of these things on the same line. And you've got you're printing your center value, then you're printing your volts. Know that you've got a comma added in here so that you can separate before from the previous print statements. And then now when we're printing temperature, we want to add a print ln so that everything after this goes to the next line. And actually, sneak peek, this is what it'll look like. So first, we've got the sensor value, the volts, all in the same line. And then after we print the temperature in degrees Celsius, and trust me, it would not be 242 Celsius. This is just an example. It goes to the next line. And so that's what print ln does. Now we'll go back and see how we determine that relationship for voltage. So if you look at the sensor specifications, which you'll often need to if you're developing code, or you can find it on online platforms like Reddit, Stack Exchange, Quora, right? It's pretty abundant in terms of resources, which is why Arduino is a really good prototyping tool. But if you look in any of these places, you'll find that the temperature range for the TMP36 sensor varies anywhere from -40 to 125 degrees Celsius, meaning that's the temperatures it can measure from. The accuracy is questionable as you get to the extremes, but that's the given range. And the voltage range, which it operates on, is between 0.1 to 1.75 volts. Again, these are statistics you can find on spec sheets. One of which is on this link here. Actually, these slides will be available to you after this if you ever want to go back and take a look. So then people are able to create a relationship between voltage and temperature. And by doing that, we can create some sort of linear set of equations. Let's say at -40 degrees, we know that the range is 0.1 because that's what they're telling us is the lower threshold. And that multiplied by our slope plus some initial value should equal -40, right? Because we're looking for the relationship between temperature and voltage. And then we're going to do the same thing for the upper end. At 125 degrees Celsius, it's going to equal 1.75 volts. And then we combine the equations together. And I'm not going to walk through this too in detail. I'm sure you're all good at math. We come to the equation that temperature is equal to -50 plus 100 times voltage. And then you just factor out the 100 from each of that, and you get temperature is equal to voltage minus 0.5 times 100. So if you multiply the 100 out, it's 100 times voltage minus 50. Same thing as this, just rearranged a little bit nicer. And so that's how you get that equation. And I know this is a little bit more complex of a situation, but you know, temperature is something that's fairly common. It has a lot of applications in health, in medical devices. If you want to do things like, you know, detecting or create a control system based on temperature, that's one thing. Measuring like a COVID temperature gun, right, a thermometer gun, that you would have to use something like this. So I thought this would be a good example for you to know and understand. Okay, so any questions about this before we go on to the actual Tinkercad build? All right, if not, let's go ahead and build the circuit. Okay, so I've logged on to Tinkercad. This is what it looks like. The first page it'll take you to is 3D designs. You don't want to go there. It'll ask you to create a 3D design. Instead, go to circuits and then click create new circuit. And it usually creates very interesting, funky names for it. So make sure to rename it to whatever you want it to be. And bear with me for a minute. My internet is a little bit slower than usual today. I'm in the middle of the woods. The first thing we're going to need is our Arduino and breadboard, right? So if you go to starters, you'll see all the components. You've got resistors, push buttons, capacitors. You've got an entire toolbox right here for you. But we just want the Arduino and the breadboard. Now I could just draw out the blank Arduino and a breadboard, but luckily they have one wired up for us. So I'm just going to drag and drop. And if you see here, the ground is connected to the negative rail, and the red, which is the color we generally use for power, is connected to the positive rail. And now we can wire the other rail by just connecting the two positive sides and the two negative sides. So now you've got your entire breadboard wired up. So the first thing we're going to do is drag out our temperature sensor, TMP36. And so you'll see I've dragged it out. And the nice thing about this is if I hover over each of the leads, it tells me what I should be connecting this to. So I'm just going to bring this and, connect it here. Can anybody tell me where this should be connected to? Just shout it out.
Is it ground?
Where
Yeah,
the
absolutely.
black wire is
Where on the
connected
rail
to.
does that connect to? Absolutely correct. And here's where you can change the color. Generally, anything you connect to ground, make sure you're wiring it up as black. Color coding is a really good practice. For simple circuits like this, it's not going to seem like much, but soon you're going to be building intricate circuits and you won't know what's what if you don't cut. I encourage go through and take the time and effort to color code. And the next thing, this one goes to power. Anyone want to shout it out? It's fairly simple.
The positive one where the red wire is connected.
Yeah, thank you. Okay, and then this one's a little bit more tricky, but should be straightforward. Which pin do we connect this to?
Is it to one of the pins on the Arduino?
That's correct. I'll refine it further. Is it an analog pin or a digital pin?
Analog pin.
Absolutely. Can someone tell me why it's an analog?
Continuous stream of input.
Absolutely. Thank you. Yay. Okay, so again, whether I start from here or here, this entire rail is powered, so I can just connect directly from here. I like to neatly organize my circuits. And so I'm going to connect this to pin A0. And I'm just going to say it's a nice turquoise color. So we've got our temperature sensor all wired up. The next sensor we're going to get, or the next component we're going to add, are LEDs. I have to go into all components so that it's not just looking for Arduinos. Okay, so now I'm going to drag this out. And then I'm going to connect it anywhere on here. Can somebody tell me what the anode connects to?
Positive.
Absolutely. And in terms of this, we're going to define positive as one of the digital pins. Remember, we can control power input or power output from the digital pins themselves. Instead of, if we connect them directly to the rail, we won't be able to add functionality. So our code won't work because the positive will always be flowing and the light will forever be on. Whereas if we connect to the digital pin, we can tell it when to turn on, when to turn off. So remember, we were powering circuits from 2 to 5. We just went over the code. So I'm going to connect this to 4 just because that's the closest. And the nice thing is you can just command copy and command paste. So now this one is going to connect to 3. I'm going to do the same thing again. And then connect this to 2. But now we need to wire the other side. What do we do here? What component do we need to add?
A resistor.
Absolutely, thank you. So we're going to set this as 220 ohms. If you set it as kilo ohms, your LED will likely not run. So make sure to set it as ohms. And again, you can command copy, command paste. I usually just like to set 1, and then that's it. You've got it all set up. The next component we're actually going to add, which is going to serve as our...
How many ohms did you say?
Yes. 220.
220. Okay, thank you.
Yes, no worries. I think so. Based on that very back of the envelope math that we did earlier, if you subtract the input voltage of 5 volts minus the voltage drop of the red LED divided by that 20 milliamps, you'll find that the minimum resistor that you need is actually 160 ohms, and you need a resistor to serve as a pull down so that there's a weak connection to ground, and it's always sort of functioning based on the code that you give it instead of a floating value. It sounds really arbitrary, but you just need to keep it grounded. So not going to go into that. Yeah, go for it.
And is it 20 milliamps for every component, or is that just for the LED?
Good question. That's just for the LED, just for the red LED. Actually, if you use an RGB LED, the max current goes up to 30 milliamps, and you can find that on the spec sheet. Okay. We can even you could probably Google something like this, and you'll see that the max current allowed is 20 milliamps, and you'll see that the forward drop is actually between 1.8 to 2.2, depending on the brand and company that you're using. So you can use that to calculate. Okay. So now we've kind of got almost most of the components. The next thing we're going to add in is the DC motor, and that'll just serve as the de facto fan in this case. Okay, and that's this component. It's fairly simple. It just needs 2 inputs. One goes to ground, and again, I'm going to make sure to color code that to black. And then the second one, this red lead, connects to power, and I'm going to just connect it to pin 5, since we don't have an output set for pin 5 yet. I should make it something else to make it orange. Okay, so now we've essentially got our entire device built out in terms of the actual components. Now we're going to go to code. So if you don't know how to use, or if you don't know how to code, Tinkercad has a built-in block function, which helps you define, the set built-in LED states. You could either be high or low, but I don't prefer this, right? If you're going to put the time and effort to learn Arduino IDE, and coding, it's a really good skill set for your future. Just go ahead and do it the normal way and do it with text. It's going to be a lot more valuable for you. So really quickly, say we just wanted to turn on pin number 2. So this LED, we're going to set that as an output. And then we're going to say, hey, pin mode to digital write. So we're giving commands, we're writing commands to the digital pin 2. We're going to set it as high. And then this delay function is saying delay or pause for 1 second. So 100 milliseconds is 1 second, and Arduino operates on millisecond time. So we want to set that as 1,000. If I set it to 2,000, it'll just pause for 2 seconds. I'm just going to say 1,000. And then after that 1 second, I'm going to set it to low. So essentially, this will create a blinking circuit for digital pin or LED number 2. And if you initialize it, you'll be able to see that your LED just blinks on and off based on this really simple code that we wrote. Now, for the sake of time, I think we're just going to go through and we're going to create the initial inputs, and then we're going to walk through the rest of the code. I've sort of built this code out here. So we talked about all of this. So let's just go ahead and enter that in, and then we can build the code for the void loop together. Okay, any questions about this so far? We can go ahead and give a quick review, right? So we're saying sensor pin is A0. Remember, our temperature sensor is connected to pin A0. And then we're telling it to start looking at the serial monitor, and that's going to be at a baud rate of 9600, basically sending 9600 bits per second. And then we're telling it, hey, for pins 2 to 5, we're going to set that as an out. But then remember, we also have pin 5 that we've connected to our digital or DC motor, so that we're also setting as an output. So I guess the easier thing to do here is just go less than 6 and write that as output, and default state is low. Does the same thing. I could either do that or just throw pin mode 5 and out. So I always get my comments confused based on all the languages, but commenting in Arduino is just ///, and that should just create or comment out whatever it is that you're saying. It's generally good practice to add comments to your code so that you or your partner or anyone that you're working on the code with understands, or if you're going back and referencing it yourself, you have a better understanding. Okay. We actually walked through all this code, given that we were sort of short on time. I'm going to go through all of, let's just take the whole thing. And then we'll walk through what the code does here. Okay, so if you recall, we went through all of this up until defining the voltage as sensor value divided by 124 storage data points from the ADC converter, multiplying by input voltage, and then defining the relationship between voltage and temperature. Now we're going to give the commands to the Arduino to make use of that temperature that we've collected. So if you go here, you'll recall that we used baseline temperature as 0. You can set it to 20, 30, whatever you want. And so what I've done here is I have said, hey, if the temperature that is being detected is less than the baseline temperature plus 10, so baseline 0 plus 10 is 10. If it's less than 10 degrees Celsius, I want all of the LEDs and the DC motor to be off. Let me comment. This is DC motor. They'll all be off. But else if, right, I'm using else if because I have more than 2 conditions. If I just had, hey, less than 10 and more than 10, it would have just been if and else. But because I have more than 2 conditions, I'm using else if. And so else if the temperature is greater than or equal to baseline plus 10, but it's also less than 20. So it's between that 10 degrees and that 20 degrees range. And if you want to declare and, you have to use and that's just the Arduino notation, right? Then I want just digital pin 2, one LED to turn on, and I'm going to declare that as digital pin 2, and using the digital write function. Basically, I'm writing a command to digital pin 2. And so that's what will happen. We'll actually go ahead and execute, and we should be able to see that. So you see here, if I've set it to 8 degrees, it's less than baseline plus temperature of 10 degrees. So all the LEDs are off. But if you recall, we created that print statement. Every loop, it's going to print the sensor value, the volts, and the degrees. And you'll see it's printing to pretty accurate values what the temperature is. And it's going to keep going based on how fast you run it. You could add a delay. Remember, we're only adding a delay of 1 millisecond here. Now, if we stop the simulation and add a delay of 1000 milliseconds or 1 second, you'll see that it runs a lot slower. And that's up to you based on your sampling rate. How fast you want to sample is entirely up to you. So the next thing, right, if we say, okay, well, it's between 20 and it's less than 30, I want 2 pins on, so 2 LEDs on to indicate that. But I also, at this point, want to turn the fan on. It's getting a little warm in here. Let's turn the fan on. But then if it's over 40, right, at all, I want you to turn all 3 pins on and make sure you turn on the fan because I'm going to be burning. So again, if we start the simulation, that's exactly what we'll see. At 3 degrees, nothing is on. Once we hit between 10 to 20, 1 LED is on. Between 20 and 30, 2 is on. The second I go over 40, all 3 of them are on. And I don't think you can see this based on the code. Let me just move a few things. Let me move the code away, but you should also see that your DC motor is turning. And now when just 1 LED is on, or none of the LEDs are on, the DC motor is off. Again, once 2 of them turn on, the DC motor, or AKA your fan, turns on. There's a lot more you could do with this. For example, you could say, well, okay, why did we stop at 30? Why is there nothing defining what happens between 30 degrees and 40 degrees? Purposefully left that gap there. You could add another LED. Maybe you add like an orange LED to define that. And actually, you could even go here and change the color of the LED. Okay, there's generally a way to, if you double click it, you should be able to change it. It's not allowing me. Sometimes Tinkercad is buggy. Okay, there we go. So I should be able to change it to, oh, okay, change the other one, no problem. So, if you run the simulation now, you'll have a green light instead of a red. It's pretty simple to start using. And the other thing you could do is you could go in and actually say, hey, if it's between 20 and 30 degrees Celsius, the fan might be on the low setting. If it's between 30 and 40, it's going to get medium, like it's going to get a little bit faster. If it's above 40, it's going to be running full speed. So these are all things you can code in, but I wanted to keep it, I wouldn't say minimal. This was kind of a lot for such a short period of time, but I wanted to give you just the basics of coding a fairly simple input and output project in Arduino and Tinkercad. Do any of you have any questions about either the circuit, the code, or how any of it functions?
I wanted to ask, you were just mentioning the speed of the fan. So if we wanted to control that, we would just do analog, right? Correct? And attach that DC motor to like an analog pin? Because we can't do that with a digital pin. Or can you?
I can't tell you that off the top of my head, but this DC motor actually connects only to the digital pin. I think there are other so if you go into, there's a micro servo that you can use. for example, and these you can maybe, you can control more accurately what kind of speed you want. I think you could even control the RPM with this. I'm not familiar with the code off the top of my head, but it should be fairly simple. It's only a line or two saying, hey, set it to this, and you could still do that in digital, I believe. Actually, if you see these values here, right, 5, 3, 5, 6, 9, 10, they've got the little tilde behind them. Basically, if you connect your digital pins to one of these, you can still create analog-like outputs with them. So you could essentially control the output of your DC motor using these pins.
Okay, interesting. Thank you.
Does that have anything to do with the PWMs? Or is
Yeah,
that
it does. Yeah. No, that's correct. Yeah, and for those of you, that's pulse width modulation. So yeah. Any other questions regarding the circuits, the code? It's not going away. Okay, there we go. If not, I think I'm going to go ahead and stop screen sharing. Maybe you guys have time to go into a breakout room for a short time, or we might be running up on time, I think.
I'd be running up on
Catherine.
time.
Yeah.
It should be fine for now. First and foremost, I do want to give big thanks to Achala. Huge kudos to her for crunching the intro to Arduino, intro to circuits, and intro to programming in 1 hour. Whereas in the fall, we had like separate 1 hour workshops for each. And I know this workshop started right when you were on the road. And you came right on time. So really appreciate how much work you put into this and just how amazing you were able to crunch everything in such a small time constraint. Thank you so much.
Yeah, no worries. It's my absolute pleasure to be here. And just for those of you, right, I'm actually sitting like right behind of waterfalls, and it goes to show you can do Tinkercad anywhere and prototype anywhere. So it's a great tool. Please be sure to use it. And if at any time, if you have questions about, Tinkercad or Arduino, I'm actually going to put my email in the chat below, and you can feel free to email me any of your questions.
We appreciate that so much. And I also want to remind and add on to that remind everyone that this was a ramp up Arduino session. So there may be a lot of gray areas, or you may be confused about how some of these operations work. So if you have any questions, don't forget to post on Slack on the Arduino Acclimate channel. And the competition deadline is in a month, so get excited on how much you will learn in the next 30-ish days. And then also take advantage of the privilege of being able to contact Achala. Achala has such a breadth of knowledge in just so many areas. Including, the biomanufacturing industry, correct? So definitely it will be related to the prompt as well. I want to also, I know we're catching up on time here, and thank you everyone who stayed. A couple of people had some classes to attend, so they had to leave early, but they wanted to extend their thanks to Achala for hosting this workshop. So I was hoping that I'm going to drop a Google form into the link. So any ideas that you have for the workshop that we're going to be doing on Project Aspire Day, where you're going to be meeting everybody in person, including your high school student partners, team members. In addition to that, I'm going to go ahead and share my screen quickly. Besides that, just a quick next steps on what you should be doing. So right after this workshop, I'm going to be uploading it to our YouTube channel and just making some quick edits and then uploading and then sending out an email to everyone with those links. And then what you should be doing is reaching out to your team members, especially the high school students, since they this workshop was only for college students or university students intended. So make sure to reach out on everyone on your team, introduce yourselves, establish a main communication platform. If Slack isn't the best way to communicate with each other, find an alternative communication platform, review the competition prompt with them and deadlines that you need to be doing. Set deadlines for yourself, how much time you'll be working on this project per week or bi-weekly, so that you are taking care of yourself first and foremost, and then also being able to work on some progress on what you need to do. And then also list some milestones in your learning priorities. So if you like really want to get into your foot in the healthcare industry, write that down, and then if you want those connections, make sure to just put it out on the Slack channel, and then we'll see what we can do to help you achieve those learning priorities or those milestones as well. Outside of this being a competition, we're more as known as like a community, so we want to really emphasize that, especially during these times when we're remote. With that, I'm going to go ahead and thank you all for coming, and hope to see you all on Project Aspire Day.